Hey everybody, this is Larry. This is oh yeah, okay. Oh yeah. This is the first day of April. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's farm. Happy April 1st, happy April Fools. There'll be no I was gonna say there'll be no fools on this video, but actually I don't know. Can't guarantee that. But we won't try to trick you. I don't even know why I said we, there's only me. but yeah. Let's take a look at today's farm, and we'll also do the weekly premium afterwards. We'll see how easy it is, then maybe I'll do a bonus one. I'm feeling a little bit more energetic today. Yeah, and if you're new to the channel, yeah, I mean it's a lifestyle type situation. This is a little bit, it's a lifestyle situation, so definitely we'll go through each farm every day, and even if you know how to do it, let's do it together, or if you think this is a waste of your time, send it to someone you hate and tell them to watch it, then waste their time or something. I don't know. It's a tough world out there, I guess. On the 1st of April, we're starting with a relatively straightforward problem, I guess. 704 binary search. Which variation is this? Let's see, right? So basically, okay. I think one thing that I need to do, I kind of have it done, but I have to kind of finish editing it. Is a binary search video. I have a standard way that I do it, and the way that I kind of think about these things is not through. It's not through pattern recognition. The way I like to think about it is just asking myself three questions that are the same, right? And usually usually it's, most of the decisions is pretty much the same, which is that, okay, do we want inclusive bounds or non-inclusive bounds, right? Or exclusive bounds. And I always choose inclusive bounds because the reason is because then now we can write this while statement like this, which means that when they converge, so that means that the range starts at 0 to n-1 inclusive, and when the range is one number, then that's your answer, right? So that's easy to do. And then the second thing that I ask is that, okay, if we have some good function in the middle, and maybe good is a kind of a terrible name, but it's basically like, for me, it's just about some sort of satisfactory, or not satisfactory, satisfied. Anyway, yeah, whether certain things is true or not, right? So here we have to define the function first, which is that we want to say, is the number in index target greater than or equal to target? Sorry, index. I use target here, and this is the target, so that's really awkward actually. Okay, fine. Maybe just current then. And index current. Right, and yeah, and then now, I mean, even without implementing this, we can just ask ourselves, okay, now if it's equal, if it's greater than or equal to, what does that mean, right? That means that that means that mid is a possible answer. So then, because it's a possible answer, we want to try to see if we can get a smaller answer, right? Basically, what we want to do is here is return the smallest number that's equal to or bigger than target, right? So given that, we go, okay, then we want to restrict our search range by making it smaller, so that and then we set right is equal to mid, and because we have inclusive bounds, we can just set it to mid because mid is a potential answer, right? And then else, then left is equal to mid plus 1. And this plus 1, maybe I think some people think of it as a pattern, but no, it's plus 1 because if this is false, that means that mid is no good. If it's no good, then left is equal to mid can never be an answer, right? Because this is inclusive. So you go to the next number on a bigger range, and that's your answer. And then now we go, I think I'm a little bit off here, to be honest. I think this should actually go to n inclusive, because the way that we structured our thing is that we want to get the smallest number, or I guess technically smallest index that has the number that's greater than greater than or equal to target. But of course, you have to leave space for having something that represents bigger than every number, right? In that case, so this should be n instead of n minus 1, and that keeps the inclusive. But then yeah, if left, and of course left is equal to right in this case, if this is bigger than, then it is bigger than all the numbers, so that means that it's not in it. If num sub left is not equal to target, we return -1 as well, and then otherwise we just return left. Remember that left is equal to right, so you can actually replace these of left or right as possible. And of course, this case this is a relatively easy thing to write at this point. And there we go. And this will be way awkward if I get it wrong. It wouldn't be surprised. These things are very easy to get wrong, but but I should probably like try a little bit more. It is nice that. Okay, target is 2. So yeah, so definitely I'm just looking at these example cases, and of course the one that you can add is just like if it's bigger than all the numbers. Yeah, okay, if that looks good, then I am happy. Let's give it a spin, and there we go. Seems like historically I get it correctly 3 out of 4 times on the first try, so that's good. But yeah, as you can see, this case, I forgot that particular case. It's very easy to do it. Yeah, that's what I get for being lazy though, because it seems like in the past that's all good. I mean, this is a very standard binary search. I'm sure you realize this. Definitely practice kind of writing it out, especially if you don't practice on easy questions, it's harder to practice on hard problems. And yeah, and the complexity is going to be O of log n, given that n is the number of elements in the input. So yeah, and O of 1 space, of course, because we only have a couple of variables and stuff like this. Cool. That's all I have for this one. Let me know what you think. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.